So unweathered rock have very low primary porosity as they are formed of interlocking crystals, which in case of plutonic rocks they crystallize from the melt, and in case of metamorphic rock there is recrystallization. So originally the original porosity, primary porosity is very less. Now weathering will create sheet-like minerals, sericite for example, micas, chlorides. So they can help in enhancing the porosity as they break down the closely packed crystalline grains into sheet-like minerals here. Then fracturing will increase the porosity by 2 to 5%. This is from a research paper. Then this we talked about. We have weathering on joints, fractures. So earlier we planes of igneous will be the first place where the weathering will start, as it has more surface area to provide the favorable conditions for weathering. Some repeated part here again. So for groundwater to occur, there should be openings which are developed through majorly faulting, fracturing and weathering. Moving on, so these are basically leading to formation of secondary porosity. Primary porosity is very less, 1 to 2%, 3 max to max. So secondary porosity, pressure release due to overburden erosion. So when overburden is eroded away, it can create something like sheeting joints. The same can go with the glaciation and melting cycles. It will also create similar effect. So let's understand it with an animation. So say here you have a country rock. In this you have intrusion of a batholith, plutonic batholith granite, or say granulate facies metamorphic rock is here, which is having high temperature. So in normal condition what will happen is the surrounding rocks will put a pressure on our rock body from all the sides, as you can see here. So it's at depth, so you will have pressure from beneath also. What happens is there is counter, that force is balanced by the forces exerted by the body against the force which are exerted by the surrounding rocks. But over time the overburden erodes away, so it can be the erosion of overburden, or say glacier is removed, so the top force will diminish to zero, or at least it will reduce in intensity in its magnitude. So the force counterbalancing it is still acting, and it will like stretch the rock in, expand the rock in towards the sky, towards the ground. So you will have greater force here, and it will lead to formation of sheeting joints like this. Moving ahead, when there is cooling of the volcanic is on surface, the magma beneath the surface, then also we can have formation of something called as cooling joints. An example is columnar joints. Here is the image. This will also create the porosity, the vertical sets of joints. It will also help our water to travel, and it will have forming of magma. Then we can have regional tectonic stresses. This we all know majorly, like if there are forces on any body, it will be deformed in a brittle or ductile way depending on temperature and other factors. So we can have formation of faults, fissures, styloid joints, means everything. So it is again enhancing our porosity. Yeah, that was example of brittle deformation. Here it is example of ductile deformation when along we have some additional uh, temperature. So it is not a brittle formation, it is a deformation, it is a ductile deformation. You will have folding. So folding also you can have extension, axial joints, expansion cracks at the crest, and contraction will again form some joints. There is a lot of creation of space. So it's again porosity. And different phases of metamorphism also lead to increasing the porosity. The original rock folding, it will create spaces between the crest, between rocklets at crest troughs, and in 3D orientation, if you can like imagine it, you will have domes, you will have basin structure. So there is a creation of porosity. The porosity is enhanced, and it enhanced to like it can increase to 10, 20% or 50% depending on whatever the deformation is. On the right you have multiple phases of metamorphism and some volcanism and magmatism associated with it. So in the starting you have a rock, forces apply from the vertical direction, horizontal direction, and then there is expansion and you this is like an example of how Earth is dynamic, so rocks can undergo various stages of formation. These are the references. Thank you. You may ask your questions now. And thank you for joining me.